Hey Royals, in today's lesson we're going to talk about unit conversions. This might be something that you've come across in previous courses, but we're going to review it all together here so that we're all on the same page. Okay, so if you think about any unit that you might measure with, so it might be a meter, it might be a centimeter, it might be time, it might be seconds, minutes, hours, all of these units can be derived from seven SI units. So these units have been accepted internationally as the base units. Okay, so there's a unit for length, one for mass, one for time, one for temperature, one for the amount of substance that is there, one for electrical current, and then the last one for luminous intensity. Okay, so we're going to take a second and define what the heck these base units are, and then we're going to show some conversions between prefixes as well as from one unit to another unit. Okay, so the unit for length is the meter. And so the meter is internationally accepted as the unit for a length. Okay, so up on the wall in the classroom, we have a poster up that has the unit for an inch. And if you look at this poster, it tells you that an inch was at one point defined as the length of 3 kernels of corn. It also defines a length as a rod, which was the length of 16 grown men's feet as they lined up for church on Sunday. So these obviously can't be great units to use because they're going to change no matter what piece of kernel you're using, or if you're using a different set of 16 men on the next Sunday. Okay, so the meter is defined as our length, and it has a unit symbol of M. Okay, mass is actually a weird one. It's the kilogram. And I say it's a weird one because a kilogram has a prefix to it. It's kilo, which means 1,000. You would think that the base unit here would be grams, but in fact, we've accepted the kilogram. And there's a video I'll show you that deals with defining the kilogram based off of universal constants. So take a look at that video when I post it. The unit for time is the second. So anything that we define can be for a period of time can be defined based off of a second. And so the symbol that we're going to use is an S. Temperature is Kelvin. If you've taken a chemistry class, you'll recognize the name Kelvin, and it's named after a famous scientist, and it's a capital K. All right. The amount of substance is known as a mole, and if again in chemistry class you define it as MOL for the amount of substance that might be in a cup or might be in a molecule or something. Okay. Electrical current is something that we will use in this class, and it's called an ampere, or amperes, and it's defined as a capital IA, and then luminous intensity is the candela, and it has CD as its units. Now, when we get into forces, we're going to define a unit known as a Newton. So if I say 1 Newton, we look at it and it's not one of these 7 SI units, but we can actually define what a Newton is based off of these SI units. And 1 Newton is actually 1 kilogram multiplied by a meter divided by seconds squared. And that equation, or this set of SI units, will make sense once we start talking about Newton's laws, and more importantly, his second law, which defines that the force acting on an object is equal to its mass, there's the kg, divided or multiplied by its acceleration, meters per second squared. And all of this will make sense once we start talking about forces. Okay, so I just wanted you to see that these units can actually be broken down. So a Newton can be broken down into smaller things. A volt can be broken down into smaller, or these SI units. Okay, so what we want to do now is we want to identify the fact that these SI units can actually have a prefix beside them as well. And that allows us to say there might be 1,000 of them or a nano of them. So like a nanometer is 1 times 10 to the negative 9 meters. Or say a kilogram, which is 1,000 grams. Okay, so the first example I want to do here, and we'll call it example 1, we're going to try to convert 250 grams to kilograms. And we're going to use a factor conversion method. And what I mean by that is that we're going to use a series of fractions to help us convert from one unit to another unit. And we're going to do this all the way through the course. And in fact, this goes into grade 12 and even on to university, you'll use the factor conversion method. Okay, so 250 grams. And if we think about it, we say, all right, 1 gram, how do I convert that to kilograms? Well, I know a kilogram is 1,000 grams. And notice that I've set up a fraction here. And I've specifically set it up so that my units for grams will divide to 1. And so now if I actually equate this, I'm going to get 0.0250 kilograms. Actually, sorry, I put an extra 0 in there. It actually comes out to 0.250 kilograms. Okay, so let's go ahead and do an example that doesn't require just simply a prefix of kilo, right? Let's go ahead and try to convert between 2 different prefixes. So we're going to convert a 0.00325 kilograms to micrograms. And you might go, what the heck is a microgram? A microgram is times 10 to the negative 6 grams. Okay, so first things we're going to do is we're going to write down the question again, 0.00325 kilograms. And let's get it to grams. Okay, so let's convert this to grams. So I'm going to say 1,000 grams is 1 kilogram. And I'm again setting up my units so that they divide to 1. Now, if I was going to look at just the units I have right now, I would have just simply a gram. So let's go ahead and get this to micrograms. So if we were to think about how many micrograms are there in a gram, we have 1 times 10 to the 6 grams in micrograms in 1 gram. So that to us now means that if we were to look at this, our units for grams would divide to 1. And I'm going to be able to just simply multiply now because my kilograms has gone away, my grams has gone away, and I'm left with just micrograms. Okay, so we're going to convert all this. If I multiply 0.00325, multiply by 1,000, multiply by 1 times 10 to the 6, I get 3,250, one more, micrograms. Okay, so that would be 3,250,000 micrograms. Okay, so let's go with one more example here. And we're going to convert between miles and kilometers. So I'm going to convert 26.2 miles to kilometers. Now, one thing we need to remember is how many miles are there in a kilometer, or how many kilometers are there in a mile? Well, if I look that up, I get 1.609 kilometers in 1 mile. And I'm going to put the mile here. Okay, so we're going to use that conversion to convert miles to kilometers. Now, why would I be interested in this? Well, if I'm looking up the efficiencies of vehicles and things, they tend to have miles per gallon, which is a US-based unit. And so us in Canada, or I guess most of the world, would like to talk about kilometers per liter, right? Or liters per kilometer, right? So let's go ahead and convert this 26.2 miles to kilometers. Okay, so what we're going to do now is I need to say that 1 mile is 1.609 kilometers. Now, this wasn't straight a conversion of prefixes because a mile and a kilometer are different ways of measuring a length, and they're not just simply off by a factor of 1,000 or 100 or anything like that. They're actually different bases of units, and a mile doesn't actually follow the SI units, right? It's something else that we're not going to deal with in this course. Okay, so miles will divide to 1, and if I multiply this through, I get 42.2 kilometers. And some of you might recognize this as the length of a marathon. Okay, so let's go ahead and do some examples where, I think this was example 3, some examples where we need, say, a double conversion, where we're converting a length and a time at the same time. So that would be, say, a speed conversion. So example number 4 here, let's say convert 35 miles per hour to, let's say, meters per second. Okay, so first thing I want to do is I want to convert my miles to kilometers, and then I'm going to convert my kilometers to meters. I'm also going to convert the hours to seconds. Okay, so I'm going to start by writing down my equation, or what I was given, 35 miles in 1 hour. I'm going to convert away from my miles. I'm going to say 1 mile is equal to 1.609 kilometers, and that allows me to get rid of my miles unit. So if I stop now, I would have units of kilometers per hour, and I don't want kilometers per hour. I want meters per second. Okay, so I'm going to then say, all right, we need to convert away from kilometers to just simple meters. So 1 kilometer, and I'm putting it in the denominator because I want my units to divide to 1, is equal to 1,000 meters. And now my units for kilometers will divide to 1. And I'm going to then multiply by, now I'm trying to work with my hours. So I want 1 hour, and I'm putting it in the numerator so that my hours divide away, is 60 minutes. But I don't want minutes. I want 60 minutes. I want 60 second, 1 minute. 1 minute is 60 seconds. Notice how I almost made a mistake there by putting my units for 60 minutes in the numerator. In fact, I need my minutes to divide to 1. So if I look at my units that I have left over, meters and seconds. Okay, so if I convert this all the way through, 35 multiplied by 1.609 multiplied by 1,000 multiplied by 1/60th multiplied by 1/60th, I get a number of 15.6 meters per second. Okay, so we'll do one more example here, and that will be an example where my units are, say, squared. Okay, so let's say I have an example here. Convert 0.05 kilometers squared to meters squared. Okay, so with this, because of the squared, that means it's actually kilometers times kilometers. So I actually have to do the conversion twice. So we'll start with 0.05 kilometers squared, and I'm going to write it as multiplied by kilometers, just so we see what we're doing here. I'm going to multiply by 1,000 meters in 1 kilometer. And what you'll notice is that I've only actually removed 1 of my kilometers. So if I stopped at this point right here, I'd have kilograms times meters, which is kind of a weird unit, and we don't really want to work with that. So we need to do this calculation one more time. So 1,000 meters is 1 kilometer, and that gets rid of my kilometers one more time. And if I actually go ahead and calculate this, I'm going to get 50,000 meters squared. Now, where'd the meters squared come from? Well, I have a meters here and a meters there. Meters times meters gives me meters squared. So this gives you an idea of unit conversions, the different types of unit conversions that we're going to deal with in this course. There is a practice sheet of questions. I encourage you to give that a shot.